So first of all, as usual, I want to recognize our Spotlight students. This week, Leo is our Spotlight student. So Leo, why don't you introduce yourself and talk about what you like most about math.
My name is Leo. I'm in third grade, and what I like about math is algebra and geometry.
All right, cool. So the way we are working on today, because we have totally 4 problems, and problem number 3 was really tough. So it's actually beyond elementary school math. So I've decided to leave it in the very end. So let's see if we have time, then we'll cover it. Otherwise, I'll give you some hints. So give you an easier problem to work on. Okay. Hold on. Let me. Okay. Let me go back. Hey guys, no need to type in the chat box. Okay. So there's no need to say hello. We already said hello. Okay, let's start with our first problem. I haven't decided who to give a solution for this problem, so I will just leave it open. So who wants to talk about this problem? If you want to talk about this problem, unmute yourself. I only, whoever the first can talk about it. Anyone want to talk about the first problem? Can you guys hear me? Okay. Yes. So Henry, do you want to talk about the first problem? No. Okay. Then okay, Leo, raise your hand. Okay. So Leo, why don't you talk about the first problem?
Well, at first, looked out that problem 1, 2, and 3 took 6 minutes. 2, 3, and 4 took 7 minutes. 3, 4, and 5. I think took 8 minutes, and so on. And so I got to 1 through 7 took 12 minutes.
Okay. 5, 6, 7 is 10, and 1, 6, and 7 is 11, and 1, 2, and 7 is 12. Okay.
And then I saw that the fourth problem took 1 minute longer than the first.
The fourth one took 1 minute longer than the first because 2, 3, 4 is 7, and 1, 2, 3 is 6, right? So 2 and 3 are the same. So 4 is 1 minute longer than 1. Okay, so you have 4 minus 1 is 1. Okay.
So then I did 5 and 2, 6 and 3.
5 minus 2 is 1 as well, and 6 minus 3 is 1. Okay.
And then I also did 7 minus 4 was 1.
7 minus 4 is 1. Okay.
And then I did 8 minus 5. 1 minus 5.
Okay. 1 minus 5 is 1. Okay.
So I saw that 1 minus was 2.
Okay, so you look at these two. So 5 minus 2 is 1, 1 minus 5 is 1. So 1 is one more than 5. 5 is 1 more than 2. So you said 1 minus 2 is 2. Okay?
And then after that,
Mm-hmm.
I did 2 minus 6 was 1.
2 minus 6 is 1. How did you find this one?
Well, I first I just did.
Oh, the last two. So 167 is 11 and 127 is 12, right? So you said 2 minus 6 is 1. Okay.
So then after I got 2 minus 6 was 1, I also got 2 minus 3 was 2.
2 minus 3 is 2. Why is that? Oh, because 6 is 1 more than 3. So 2 minus 3 is 1. It's 2. Okay.
Which meant that 1 minus 3 was also 4.
Since 1 and 2, 1 is 2 more than 2, 2 is 2 more than 3. So 1 minus 3 is 4. Okay.
And then I did, and then after that, I did that, because of that, I tried to find 1. So I saw that, I saw that it basically 1 was equal to 6 plus 2 plus 4 over 3.
1 equal to 6 plus 4 plus 2 divided by 3?
Yeah.
Because look at the first one. 1 plus 2 plus 3 is 6. So you said 1 is 4 more than 3. 2 is 2 more than 3, right? Right? 1 is 4 more than 3. 2 is 2 more than 3. And 1 is 2 more than 2. So you just, you have the relationship of all these three. And then you can come up with 1 is equal to 4, huh?
Yeah. And then after that, I found that 2 would be 2.
2 equal to 2, okay?
And then I wouldn't have to find 3. All I have to do is that 5 is 1 more than 2, so I got 2 plus 1 equals 3.
Since 5 is 1 more than 2, so 5 is 2 plus 1 is 3. So 3 minutes. Okay? Well, this is an interesting way of solving this. So you're trying to find relationships among these different problems, and then you find all these 1s and 2s, and then you try to come up with the 5, right?
Yeah.
Any other ways to solve this?
I have another way.
Okay, who's that?
Isaac.
Isaac? Okay, go ahead.
First, I added 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12.
Okay, you add them up. Is 63.
And then I realized that 1 was in there 3 times, and all the numbers were in there 3 times, so I divided by 3.
Awesome. So the way I gave the problem for every set of 3 problems, I do from the smaller number to bigger number. So 167 and 127. Let's, instead of writing it this way, let's do 6 plus 7 plus 1 is 11, and then 7 plus 1 plus 2 is 12. Then if you look at each column, you have 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 1, 3, 4, 5, 6, 7, 1, 2. So each problem show up 3 times, and you add them together is 63. Okay, keep going, Isaac.
And then 63 divided by 3 is 21.
Okay, 63 divided by 3 is 21. So that means adding up 1 through 7 is 21. Okay, 1 plus 2 plus all the way plus 7 equals 63 divided by 3 is 21. Good, keep going.
And then I took away 21 from 2 plus 3 plus 4 with 7. So I did 21 minus 7.
So, because I asked for problem number 5, so you need to figure out, 21 is adding them up together. So you remove 2, 3, 4, and what else did you remove?
I also removed 167.
167. Okay, 2, 3, 4 is 7, and 167 is 11. So basically do a 21 minus 7 minus 11. That's 3. That's problem number 5. Good job, Isaac. And congratulations, you're a perfect square 2 this time. Good job. Okay, so this Isaac's way will be my way of doing it, but Leo did it a very, very interesting way too. So he was trying to find patterns and then come up with these 1s and 2s and then reduce. We call this elimination. Eliminate some of these problems and then leaving 5 at the end. Okay, good. So let's move on. Next one. Huh? Kyle has a, let me see. No?
Yeah, go true.
Okay, that's okay. So we have to move on to the next one. Because some of these problems are very tough. So, okay, the second one. Is Raghav on the line? Is Raghav on the line? Okay, so he's not here. So I meant to let him because he was the fastest one to figure this one out. Who want to talk about problem number 2? Who want to talk about problem number 2? You can unmute yourself. Okay, Kyle, you're raising your hand? Go ahead.
So I figured out that the way to solve this is if it is like x squared, it is equal to 8 minus x squared minus x squared.
Hold on, let me draw this picture first.
Okay.
So this is 7 by 7. 1, 2, 3, 4, 5, 6, 7. 7 by 7. 3, 4, 5, 6, 7. Okay, and then the middle was empty. Okay, there's no tiles here. Okay, Kyle, keep going.
Okay, so I kind of figured out that if you use the any squares bottom corner for the ones that's just the square itself, and to count that as one place. For ones, I saw that it's 7 minus 1 plus 1, which is also 8 minus 1.
I don't get it. Sorry. What do you mean?
I mean, like, so I used one of the corners, maybe the top corner. I used the bottom corner.
Okay, you start with the bottom corner. Okay.
Bottom, no, I mean like, for the squares, like there's 1 squared,
Here.
1 squared, 2 squared, like those, 3 squared. So for x squared, it's equal to 8 minus x squared minus x squared.
I still didn't get it.
I don't know how to explain it.
Okay, let me have a try on this one. Okay, so this is really a counting problem. So you're trying to count how many squares are there, right? So let's start with a 2 by 2. Okay, start with a 2 by 2. Because if it's 1 by 1, there was only 1 square, right? So how many squares are there in 2 by 2? We have 1, 2, 3, 4, and 5, right? We have totally 5 squares, correct? If it's 3 by 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the smallest square, 1 by 1 squares, we have 9 of them, right? And then we can also have 2 by 2 squares. 2 by 2 squares. 1, 2, 3, 4, 4 of them. Okay? And then there's also 3 by 3 squares. There's 1. You add them up. 9 plus 4 plus 1, this is 14, right? So the same way we can figure out how many squares we have for 7 by 7 squares. Okay? So we start with 1 by 1. So within the 7 by 7, if it's 1 by 1, we have 7 squared, that is 49, right? If it's 2 by 2, we have 6 squared, that is 36. Okay? Think about 2 by 2. So like this, 1, 2, 3, 4, 5, 6, right? So this is one row, we have 6. We have 6 of these rows, so 6 squares. 3 by 3 squares, we have 5 square equals 25, right? And then 4 by 4 square, we have 4 square equals 16. And 5 by 5 square, we have 3 square equals 9. 6 by 6 square, 2 square equal to 4. 7 by 7 square, we have 1 square equal 1. Okay, add them up. Add all these numbers up. We know how many squares a 7 by 7 squares cover. Okay, so let's add them. So 50, 20, that's 70. 70 plus 49, 115 plus 25, 140. Okay, I'm hoping I did the arithmetic correct. So if this was a 7 by 7 square and there's no empty squares in the middle, it will be 140. But since there's an empty space in the middle, we have to remove all the squares that's with this empty square in the middle, right? We can count it the same way. Again, this is a counting problem. Every time we count, we have to follow a sequence. Okay, so look at what I count. When I count 7 by 7 squares, how many of them are covered? So we started with the smallest square and then the second smallest and keep going up, right? So the same way. So how many of them are, how many squares are involved, had this, middle square involved, okay? So 1 by 1 square, we have only this one, right? We have 1. 2 by 2 square, we have 1, 2, 3, and 4, right? 2 by 2 square, we have 4. And 3 by 3 square, this is tricky. 3 by 3 square, depending on where we put this square, okay? So start from here. Let's say put this square in the corner. 1, 2, 3, 4, right? We have 4 of these in the corner with this square in the corner, okay? But that's not it, okay? What about this square is in the in the middle of one side? So we have 1, 2, 3, 4. Okay, another 4, right? So that's with this square on one side. Okay. Then how about this square in the middle? In the middle of a 3 by 3 square. Then we have 1. Okay. So this is 9 of these. Okay. And then the same, we can count 4 by 4. Okay. We also do it, 4 by 4 on the corner. 1. Yeah, Leo, you have something?
All the 4 by 4 squares at least have included the empty square.
Correct. All of the 4 by 4 squares have to include this. When I draw the first one, you can see it. Okay. So we have this, regardless where you put a 4 by 4 square, you have to have this square in the middle. So all the 4 by 4 squares is 4 square equal to 16. Okay. And all the 5 by 5 squares have to have the square in the middle. So you have 9 and 6 by 6. You have 4, 7 by 7. You have 1. So you add up these numbers. Okay, 1, 4, 9, 16. So what is this? 5, 5, 10. 10 plus 16 plus 18. So this is 34 plus 10, 46. Okay, 140 minus 46 equals, oh, is it supposed to be 90? I think I missed something. 44, sorry, 44. Minus 44 equal to 96. That's the answer. The answer is 96. But either way, Leo, what's the either way?
Well, at first there's that for 1 by 1 square, it would be
sorry, let me interrupt you for now. So let me finish my method first. So we have 96, but when you look back, we didn't have to add up, all the 7 by 7 square, assuming there's no such 1 by 1 square. Okay, we didn't have to add up all of these numbers and then add up all of these numbers and do subtraction, because we know when we start with 4 by 4, all of these are involving the middle space. So we didn't have to add these at all. All we need is to add 1 by 1, 2 by 2, 3 by 3 squares. So that will be 49 plus 36 plus 25, and then minus the 3 by 3 and 1 by 2 by 2 and 1 by 1, minus 1 plus 4 plus 9. That's it. Okay, we didn't have to do so many additions and subtractions. Okay, so that complete my method. So Leo, go ahead.
Well, first I saw that for a regular 7x7 grid, it would be there for one square there will be 7 by 7, but there's an empty hole like in the middle. So I just saw the empty hole for 1 by 1. There was only one square and a 1 by 1 square.
Okay.
So it would be 7 squared minus 1 square.
Okay, so so Leo was counting. Let me take a new one. So Leo was counting the size of these squares. So for 1 by 1 square, Leo said there are 7 square minus 1 square. Okay.
And then what's equal 48?
Equals 48. Okay.
For 2 by 2, I did it equals 7 minus 1 square.
7 minus 1 square.
And then minus 2 square.
Minus 2 square. Because for 2 by 2, when you have the middle square involved, it will be on the side. So it will be either this like this, or like here, or here, or here. So that's 2 square. Okay, equals 36 minus 4 equals 32. Okay.
And then I did for 3 by 3 square. It would be 7 minus 2 square. Minus 3 square.
Okay, so this is 25 minus 9 equals 16.
And then once I got to the 4 by 4,
okay,
I saw that it would evaluate to 16 minus 16, which equals 0. So I knew that like it will keep on going to negative.
Okay.
So just stop right here.
Okay, you stop right here.
And just count it 1 by 1, 2 by 2, and 3 by 2.
Okay, you add up these. Good job. So this is an easier way to do this. 32 plus 16 equals 96. Okay, good. All right, so let's move on to any questions on this one? Let me see if there's any question. Okay, good. If no question, let's move on. I will skip problem number 3 for now. Let's move on to number 4, question number 4. Okay. Okay, so this is a magic number. You know, this is an arithmetic problem. So I have a magic number. So this number is A, B, A, C, D, D. And this number basically has 3 prime factors. These are EF, BE, and GD. Okay, these are prime factors. And then 2 of these prime factors multiplied together, that's E, G, H, F. Okay, then you multiply all of them together, that's A, B, A, C, D, D. Then all these A, B, C, D, E, F, G, H, they are different single-digit numbers. So I ask you to guess what this magic number is. Okay. Well, since I plan to have Leo talk about this because he was the fastest one to do this, but he already talked too much for this session. I want to see who want to talk about this. If you want to talk about your method for this problem, just unmute yourself and talk about it. We have 10 minutes. Anyone want to talk about this? Well, several of you had this this question right, so please. Oh, nobody raising hand? So I guess probably this homework is too tough. So next one will be a little easier. So, okay. Then I guess since Leo, you're the fastest one, so why don't you go ahead and talk about this?
Well, I first saw that E and D couldn't had to be 3, 7, or 9.
So E and D has to be 3, 7, 9. Why is that?
Because well, it can't be 5 because then either BE or GE would have to be a multiple of 5, and it can't be.
Hold on. So let's go back. So D, F. Oh, I'm sorry. The prime numbers F, E, and D, they cannot be 5. Okay, F, E, D cannot be 5. So I hope you all understand this, because if it is 5 and it's a 2-digit number, it must be a multiple 5, then they cannot be prime. So since they are prime, so F, E, D cannot be 5. Okay?
Wait, I think you wrote EGHE instead of EGH.
E, G, H. Oh, because okay, let me. E, G, H, F, because I was writing underneath F. It looked like a E, but it's a F. Okay?
So that first I saw. So then I saw that E and D had to be 3, 7, and 9, because if it was if either E or D was 1, then F would have to either equal E or D.
So basically, you're saying E and D cannot be 1. So if E and D, either one of them equal to 1, then E, G, H, F cannot end with F. It must be end with either E or D. So it's that ED must be, it cannot be the 1. So ED has to be 3, 9, 3, 7, 9. Okay?
So then I saw that F squared a unit digit of D.
Okay, so EF times EGHF, the unit digit is F squared. Okay, F times F equal to D. So F squared as a unit digit of D. Okay?
So that meant that D had to be 9 and F and E had to be 3 or 7.
Okay, so since D is a square, it's the unit digit of a square number. So it cannot be 3. So ED must be 3, 7, and 9. So D cannot be 3 or 7. Let's look at 3 or 7. They cannot, it's not a square number. So D has to be 9. So at this point, Leo figure out D. D is 9, D is 9, D is 9. Okay?
And then I saw if E was 7.
So since D is 9, so F must be either 3 or 7, right? Okay?
Then I saw that if E was 7, then EGHF would be too big.
Okay, so if E equals 7, okay, and then so this will be 70 something. EF will be 70 something, and then EGHF will be 7,000 something. 7,000 something. Okay, so 70 something. 70 times 7,000. Okay, you what? Why is it too big?
Because I saw that that B and so far we know that B and G cannot be 3, 7, or 9.
Okay, B and G cannot be 3, 7, 9 because we already figured out E and F must be 3, 7, and D is 9. Okay, D is 9. Okay.
And then I did that, and then I just wrote down all of the numbers that B and G could be.
Okay.
So I did 1, 2, 4, 5, 6, and 8. So I saw that the largest possible for B and G would be 8 and 6.
Okay, 8 and 6, 8, and G will be the same, 1, 2, 4, 5, 6, 8, because they cannot be the same, so it has to be 8 and 6. Okay.
And then I tried.
Or like this.
And then I tried 89 times 67. And it was just over 5,000.
Okay, so even you try 90 times 70, it's still not as big as 7,000 something, right? Okay, so E cannot be 7. So E cannot be 7. E
has to be 3.
cannot be 7. So E has to be 3. So now we figure out E is 3 and F, then F is 7, right? Yeah, so F is 7.
So then after that, I just
E is 3, F is 7. Okay.
So then after that, I just multiplied to
So EF is 37, okay? And E is 3, we know E is 3. E is 3, F is 7, okay? Keep going.
Then I took on, and then after that, I found EDHF was 3,827.
Okay, so let's not jump yet. So because E is 3, so this is 3,000 something. Then you can figure out B and G, right?
Yeah.
So B and G, something BE is I mean they cannot be 1 and 2 then, right? Because if it's 1 and 2, we cannot multiply equal to 3,000 something. So B and G won't be 1 and 2. So it's only 40 and 40s and 50s. Is that correct?
Yeah. So I saw that B times G had to be around 30.
Okay, B times G has to be 30 something.
I saw that 4 times 5 was too far away from me.
Okay.
So
4 times 5 is too small. Okay.
then I saw 5 times 6 would be exactly 30.
Okay.
But it wouldn't work because if 6 was like 63 or 69, it would be a multiple of 3.
Okay. So G cannot be 6. G cannot be 6 because D is 9. G cannot be 6, otherwise it's a multiple of 3. Okay.
So it had to be 4
And
8.
G cannot be 4 either because 49 is a multiple of. Okay, so we were trying to figure out B and G. Okay, Leo, go ahead, continue.
I saw if G was 4 and B was 8, 49 wouldn't be prime.
So G cannot be 4, right?
Yeah. So B had to be 4, D had to be 8.
So B has to be 4 and G has to be 8. So it's 43. BE is 43 and GD is 89. Okay.
And then I multiplied 43 by 89.
43 times 89. Uh, 3827.
Yeah.
3827.
Then I multiplied 3,827 by 37.
Okay, by 37. I think you got 141,599.
Yeah.
Good. All right. So that's how we got this number, right? 141,599. Any questions on this? You can unmute yourself if you had any questions. Okay, let me talk a little bit more about this problem. Okay. So I bet in Math Olympia, I mean, most of you are elementary school students. Many of you have participated in Math Olympia contest. So very often you see those A, B, C, D, numbers, and they gave you, something divided by something, or a number multiplied by another number equal to another number. But all these numbers, all these digits, are marked up by these letters. Okay, and you were guessing. You were asked to guess which numbers are these letters. So this is one of the more difficult problems. So you rarely see this in Math Olympia. If you're participating in AMC 8, you rarely see this level of difficulty in AMC 8 either. But the reason I gave you this problem is that this problem really gave you a lot of clues to try to figure out these letters. For example, one of the things, if it's a prime number, and if it's a two-digit number, a two-digit prime number, then that number cannot end with 5, right? So that's one of the things you have to figure out. Another thing is, when you do BE times GD, so when you look at, the 10th digit, they multiply together, there's a range. So once you figure out that range, so they cannot be 7 or something, then you suddenly narrow down the search space. You don't have that many numbers to enumerate. And then because they're prime, so for example, they're prime, so G9 G9 cannot be 49. 49 is a square of 7. Cannot be 69 either, right? So there are things you can, using these hints, these clues, you can narrow down your search space, and finally you can find the answer to this question. Okay, so this is probably on the difficulty level is very high. I want to introduce you to another similar problem. So I made up this problem. There's another problem Leo made up. So I want to direct you to that problem as well. So if you go to my website, education, there is a book called Random Math Problems. Click Random Math Problems. So this was the question you were working on from last week. This my magic number. And there's another one, more post. Leo's magic number. Okay, so there's another problem, another similar problem. I recommend you to look into this problem as well. This is online. You can go to my website and you can it can direct you to this blog, and this blog posted a few interesting problems. If you're interested, you can solve it. This is a very similar problem to the one I had. This is probably slightly more difficult. So see if you can solve this one. Okay. Again, using similar rules and clues and constraints. For example, 2-digit prime cannot end with 5, and use the range. Use some of these arithmetics to figure out. Okay. Any questions? So if no questions, since this is a new session, not a new session, added session, we have time to go over the most difficult problem. This is actually a middle school problem. This one, okay. So this is basically saying there are 10 students, and I want to divide them into 5 groups, okay? 10 students into 5 teams, And how many different ways we can divide them, okay? None of the students had this problem solved, okay? Actually, this is even very difficult to middle school problems, to middle school students. So let's break this down. So at first, I give you a hint, okay? Let's start with 2 students. If I have only 2 students, and I want to break them into 2 teams. Since we don't have many students here, you can unmute yourself and just speak freely. Okay? Well, please, we have 11 students who can join this session. You can unmute yourself, and I want to make this a discussion. If I have 2 students, I want to make 2 teams. How many different ways we can do this? You can unmute yourself and give me an answer. Yell the answer.
2.
Leo said 2, and that's wrong.
1.
1, all agree? You can mute yourself. No need to type, just say, yeah.
1.
Good, okay, I see William John. 1. Good.
I agree.
So this is not 2, right? So the reason it's not 2, this is like, if we have 2 students, we divide to 2 teams, means each team had 1 person, right? 1 person. So 2 students, 1 person. This is not 2 choose 1, okay? 2 choose 1 is 2. But think about it. Once we choose the 1, the other one will be a team, okay? So let's say there's team A and team B. If we have student 1 in team A, then student 2 must be in team B. And if we have student 2 in team A, student 1 must in team B, right? So these two grouping methods, they're the same. So this is really count as 1. So exactly, we do 2 choose 1, and then divided by 2, because these 2 are the same, okay? So this is 2 students. Let's move on. What if I have 4 students? I have 4 students, and I want to divide them into 2 teams. Team 1, team 2. How many different ways we can do this? 4 students divided by 2 teams, and I want these 2 teams with equal number of students. So each one of them has 2 students. How many different ways we can do this? I'll give you half a minute to think about this. And once you have the answer, just tell us, don't tell us the answer directly, and tell us how you find it.
first saw that the first team, once it was chosen, then the other team was basically also chosen. So I just did go choose two first, and I got first I did go choose two.
Okay, 4 choose 2. Yeah.
But the amount of ways to order the two teams would be 2 factorial.
Okay.
Which is 2, so I divided by 6 by 2.
So this is the same deal, right? So once we choose one team, the other team is set. So no matter you start with team 1 or team 2, it doesn't really matter. So once you do 4 choose 2, it's 6. Okay. You can get 6 different teams. Then you divide it by 2 factorial. It's basically 2 factorial because you can arrange team 1, team 2. You can do T1, T2, or T2, T1. So 6 divided by 2 is 3. So you have 3 ways of separating 4 students into 2 teams, with each team having equal amount of people. Okay. So let's move on a little more difficult. What about you have 6 students and you want to divide them into 3 teams? Team 1, team 2, team 3, each team 2 people. If you have the answer, just yell. And Leo, please keep quiet this time. Six students divided by 3 2-people team. If you have the answer, you can just tell us. Unmute yourself and talk about your solution.
10.
10? Who said 10?
Raga.
Raga? Okay. Tell us how you got 10.
First I did 6 choose 3, which is 20.
Why did you do 6 choose 3?
Because there are 3 teams.
But each team only had 2 students.
Oh.
Try again. Anyone get an answer? If you have an answer, if you have figured out the solution, just unmute yourself and talk about it. And Raghav, I meant to let you talk about problem number 2, but I think I know I received an email from your parents and saying you were in another meeting, so you missed that. Sorry. Six people making 3 teams with each team 2 students. You guys need more time, or do you want me to talk about the solution? All right, so for the interest of time, so let me give you some hints, okay? We have 6 students this time. Okay, let me start with the new page. We have 6 students this time. Okay, and let's say we have team 1, team 2, and team 3. Okay, team 1, 2, 3. For the first team, there are 2 students. How many different ways we can do 6 students, pick 2 to send them to team 1? So that will be 6, choose 2, right? And after you choose 2, how many students left? There are 4 students left. Then how many, for team 2, we need to pick 2 students too. So that will be 4, choose 2, right? And then after you choose this 2, there will be 2 more, 2 students left. By default, they go to team 3. So that will be 2, choose 2. And how many different ways of doing this? You multiply them together, okay? However, this is not over, okay? This is really assigning teams, team 1, team 2, team 3, treating these teams, team names differently and, arranging them just in the order of team 1, 2, 3. But for these 3 teams, we can arrange them team 1, team 2, team 3, or team 1, team 3, team 2, or team 2, team 1, team 3, team 2, T3, T1, or T3, T1, T2, and T3, T2, T1. So there are totally 3 factorial, 6 ways of arranging the order of these teams. So once you got this one, you got these, the students chosen for 3 teams in the order of T1, T2, T3, or any order, you have to divide them by 3 factorial. Okay, so this equal to 6 choose 1 will be 6 times 5 divided by 2 divided by 1 times 4 times 3 divided by 2 by 1 times 2 times 1 divided by 2 by 1 divided by 3 times 2 times 1. And this equals 15. So there are 15 ways of dividing 6 students into 3 equal sized teams. Okay? Got it? If you got it, just nod your head or put a thumb up. 6 students. But I want to divide them into 3 teams. Okay? 3 teams. So this time I don't set a constraint of all team with equal student. How many different ways we can divide these 3 teams? So first let's look at team size. Okay. So this could be 1, 1, 4. Of course, the team will have non-zero people, so at least 1 person in the team, right? So or 1, 2, 3, right? Or the team may have 2, 2, and 2. We already figured out this one. This one we said there are 15 ways of doing this 2 to 2. Okay. So let's look at this how we can deal with 1, 2, 3. This is the easier one. Okay, 6 students into 1, 2, and 3. The 3 teams. Each team has different number of people. So one team has 1 person, and one team has 2 person, and another team has 3 person. Okay. So how many different ways we can assign a team so that the team size is 1, 2, 3? Let's do this. So first 6 choose 1. All right. After you choose 1, there are 5 students left. Then there will be 5 choose 2. Okay. After you choose these 2, there will be 3 students left, or 3 people left. There will be 3 choose 3. Okay. We multiply them together. This time we don't have to divide them by 3 factorial or something, because the team size is different. So 3 teams, doesn't matter which first, which second. So 3 teams, there are 3 distinct teams. Okay, so there's no such situation that we assign 4 people left. We assign 2 teams, equal team size. Every time you get these 2 students, the other 2 automatically form a team, or vice versa. Okay. So let's see, this is 6 times 5 times 4 divided by 2 times 1. This is 60, okay? 60 ways of doing this. And you may be wondering, what if, I started picking the 3 first? So let's see if we do this differently. So we'll do 3, 2, 1. Let's see if we're getting the same answer, okay? First 6 choose 3. And then after you choose 3, there are 3 students left, 3 people left. 3 choose 2. And after that, you have one student left, one choose one. Okay, so multiply them together, you get 6 times 4 times 5 divided by 3 times 2 times 1. 3 choose 2 is 3, 1 choose 1 is 1. So this is equal to 20 times 3 equals 60. No matter which one you pick first, you always get is 60. Okay, so this 1, 2, 3 is 60. Right. So next one, let's see what we got for 114. So let me crop the tiny space here. Okay, 6 into 1, 1, and 4. Okay, so for the first one, we'll do 6 choose 1. After you choose 1, there are 5 students left. We'll do 5 choose 1. After that, there are 4 students left. 4 choose 4. Okay, we will multiply them together. And look, there are 2 teams with the same size. So that means no matter you place the first, select the student for the first team first or the second team first, they are getting the same result. So in this case, we have to divide the permutation of these 2 teams. We have to divide them by 2. 2 factorial divided by 2. So this will be 6 times 5 times 1 divided by 2 is 15. Okay, so 114, we're getting 15. Add them up, we're getting 90. So in total, there are 90 ways to separate 6 students into 3 teams, regardless team size. Okay, and I will leave the 10 student question to you guys for further exploration. Okay, again, this is a middle school / high school problem. So if you can't figure it out now, that's okay. Don't worry about it. But it's good that you heard the solution at least one time. Okay, and think about it. It's more important you spend time on this problem than figuring out the right answer. Okay. So I will see you next time.